Welcome to GATE CSE. We'll solve very interesting and GATE standard questions today on the properties that you have learned so far, the basics of matrices, okay, and its properties. So before you start solving these problems, I recommend you please watch the previous 3 videos so that you have got the sufficient properties understood all these problems. Okay, so let's begin. A 3 cross 3 matrix A satisfies A plus A transform equal to 0 and A cube equal to 0. Then which of the following statements is true? So what they are saying, there is a 3 cross 3 matrix, say A, and then they have mentioned the property A plus A transpose is equal to 0. This means what? You can write it as A equal to minus A transpose. This means what? This is the skew symmetric matrix property. If A is equal to minus A transform, then it is skew symmetric. Now, and also they are given that A cube, that is multiplying matrix 3 times, will give me 0. And which of the following is statement is true? Okay. So even though they are given 3 cross 3, let us test it for 2 cross 2 also. That's so that it holds. So let me say take a skew symmetric matrix. Okay. Let's say skew symmetric means diagonal elements are 0. So let us say this is minus A and this is A. Now let A equal to this matrix. A square, let's find the A square because to check A cube, okay, and then see which properties holds. So A is not equal to 0 or A square is not equal to 0 or A equal to 0 or A square equal to 0 or A must be diagonal. Let us check. Let us find A square. So find 0 A minus A 0 into 0 A minus A 0. So this will be equal to 0 minus A square is 0 into this is 0, then minus A into 0 into 0, then minus A into A minus A square. Okay. So this is my matrix. So I can write it as minus A square common 1 0 0 1. So this is nothing but minus A square into I. Now A cube equal to 0 they are given already. So let us find A cube also. So this is minus A square I into A is A cube, right? This is A square, that is that I found out here, and then A. So I into A is equal to A only. So this is minus A square into A, okay, is equal to A cube. So A cube they have mentioned it as 0. So let us say A cube is 0. What it means? Minus A square into what is A? My A 0 A minus A and 0. This gives symmetric matrix. Now, so this should be equal to 0. When this will be 0? So it is the 0 is this product is only 0 when I can have A equal to 0. So only when A equal to 0, this A cube will be equal to 0. Okay. That means what? If I put A equal to 0, that means it becomes a 0 matrix. Therefore, A is equal to 0 matrix. So option A. Now, A square is not equal to 0 because already you found out A square is not 0 unless A is equal to 0. Now, if A equal to 0, then A square will be equal to 0 implicitly, right? So this is also A must be a diagonal. So A is not a diagonal because it's a skew symmetric, hence the diagonal elements are 0. Okay. Next, which of the following are always true? A scalar matrix is diagonal. Okay. So a scalar, every scalar matrix is a diagonal. Is this statement true or not? Yes, because the what is scalar matrix? So K is a scalar value into IN. Identity matrix is a scalar matrix. This is a scalar matrix. So if you take here, so this, for example, if I say 2I2, that means what? 2 into 1001. This will be equal to 2002. So every scalar matrix is a diagonal matrix. What is a diagonal matrix? Other than diagonal elements, all the other elements are 0. So this is true. Second property. Even diagonal, every diagonal matrix is symmetric. So if this is a diagonal matrix, it is symmetric because A transpose is A equal to A transpose. If I take the transpose of this matrix, again I will get same 2002. So this is also true. Next, C. A skew symmetric matrix can have non-zero diagonal entries. No. Definition of skew symmetric matrix says that all the diagonal entries should be 0. This is not true. Then D. The 0 matrix is symmetric and skew symmetric. The 0 matrix means all zeros. Okay, for example, the 2 cross 2 0 matrix. So for symmetric, it should be A is equal to A transpose. So this is true. I will get the same matrix. Then A must be equal to minus A transform for skew symmetric. So 0 is equal to minus 0, right? 0 is equal to minus 0. So that means what? The both symmetric and skew symmetric. Next, consider a 4 cross 4 strictly upper triangular matrix A with all ones above the diagonal. Consider a 4 cross 4 strictly upper triangular matrix with matrix A with all ones above the diagonal. Compute 1, 4 entry I, j they are given in A cube. Okay, strictly upper triangle. Upper triangle you already know. Okay, all the elements above the diagonal, principal diagonal element should not be 0. But strictly means including the diagonal element should be 0. Only above the diagonal element. Strictly means above the diagonal elements it should be non-zero, and they are given all are ones. So let us say this is, they are given it as the matrix A is equal to like this 4 cross 4 0 1 1 1. So 0 0 1 1 0 0 0 1 and then 0 0 0 and 0. So this is what is the matrix. Strictly upper triangular means diagonal should also be 0. Only this above element should be 1. That is what they are saying. No, they are saying if you multiply it 3 times, that is if you find A cube, then in that result what is 1, 4? 1, 4 means this element in A cube. Okay, A cube of 1, 4. You can multiply and then find it, but there is a property. So there is a property. Let me write it. It says any non-zero entry in A power k. Okay, A power k means k is 3. Okay, so k moves exactly k steps above diagonal. Okay, from k, from A. Okay. That means what? If this is my matrix A, if I take k times, so this in the product, this element, whichever I am choosing, that element will move, okay, exactly k steps above the diagonal. Suppose if I take this element, say, okay, this element, okay, in strictly upper triangular matrix, when I take a product, so what they mean to say is AK of Ij is not equal to 0 if and only if I minus j, okay, sorry, j minus I is equal to k, exactly k. This is the condition. So What is that they are saying? For strictly upper triangular matrix, when I multiply k times that matrix, that element, any entry which is non-zero, okay, which is non-zero means how many steps it is moving ahead in the above the diagonal is k steps, and exactly j minus I, how it is moving, right? So from j minus I indicates what? How many steps it is moving in the result. So if you take the resultant matrix, you can verify it. So this will be equal to k. That means what? For our given condition, for our given problem, this should hold. If this holds, then only I can calculate and say that same element has moved k times. So let us see there. What is k? Is k is equal to 3 in our example. I equal to 1, j equal to 4. So j minus I, that is 4 minus 3 is equal to 3, and that is equal to my k. Therefore what? This element 1 comma 4. What is 1 comma 4? 1. Okay, this is 1 comma 4. 1 comma 4. This is 4. This element has in the product has moved k steps. So that means what? This element will be still there and it is non-zero. If there is any other element also, the same property applies, not only for one. Okay. So that means what? In my product also this element will be 1 only. That is the meaning. So answer is 1. This applies, this property applies only for strictly upper triangular matrix. Strictly upper triangular matrix. So you should be careful about this. Strictly upper triangular. Okay. Next. If A equal to 1101 and B equal to 1011, then compute AB minus BA. Okay. So when we learn the orthogonal and normal matrices, different types, then again we can solve using those concepts also, but you can just find the product here. So AB is 1101, and then this is 1011. Okay. So I will get AB is equal to, if you calculate, I will get it as 2111. Similarly, BA is equal to 1011 and then 1101. So BA I will get it as minus, I have to take, no. So this is AB minus BA. BA will be 1112. So this will be equal to 100 minus 1. Now you check. Is it a zero matrix? No. Is it a diagonal matrix? Yes. All the diagonal elements are non-zero. This is a diagonal matrix. Is it upper triangular matrix? No. So is it a lower triangular matrix? No. Okay. So that is the answer. Diagonal matrix. Next. For A comma B of same order, two matrices A, B are of same order. Which of the following is are always true? Okay. Always true. A plus B transform equal to A transform plus B transform. Okay. So let's say, so this is a straightforward property, right? Problem. So first is true. A plus B transform equal to A transform plus B transform. Property is already seen. So this is true. Second, B. AB transform is equal to B transform into A transform. This also property was seen. These are standard properties. Then AB transform equal to A transform B transform. This is not always true. Also discussed. Then trace of, so this is true, this is not true. Then trace of AB equal to trace of BA. So by the properties, this is also true. That is, I can find trace of AB. This is equal to trace of BA. Okay. This is also true. Next. If A equal to 1201, compute the entry 1, 2 of A power 5. If I multiply this matrix 5 times, find the entry 1 comma 2. 1 comma 2 means this. So see, there is a shortcut here. If the matrix is of this form 1, say some element b, and then 0, and then 1. So this can be any value. Okay, only thing is this should be fixed. This element should be fixed in a 2 cross 2 square matrix. Then I can compute a power k, okay, a power k of that entry, whatever this value is there, no, that 1 comma 2 here, comma 2 will be always be equal to k into b. So here I am finding a to the power 5, 1 comma 2. This will be 5 into b is 2 here, so 10. So that in the product it will be 10. The 3 cross 3 matrix A satisfies A transform equal to minus A. Then which of the following statement is true? See, what it means, A transform equal to minus A means it is a skew symmetric matrix. So diagonal entries of A are 0. That is the property of the skew symmetric matrix. A is diagonal, not a diagonal matrix, because all the diagonal entries are 0. This is not true. Trace of A equal to 1, no, because all diagonal elements are 0, hence the trace will also be 0. Then ACR is equal to I, no, this is also not true. The square of two skew symmetric matrix need not be identity matrix always. Next, for any n cross n matrix A, which of the following are always true? Okay. So A plus A transform is symmetric. Okay. There is one matrix, and then the transform of that matrix is symmetric. That's what they are saying. So that means what? Let us say this is some matrix B. So for this entire matrix, they are saying for this entire matrix is symmetric. You have to test that. This is first option what you are testing here. So that means what? When it is symmetric, it is only symmetric when B is equal to B transform, right? So let us take B transform. B means A plus A of T transform of this. So this will be equal to A transform. This is a property I am directly applying. Transform over T. So this is equal to A transform plus A. So A transform plus A means what? This is B. So that means what? B transform equal to A transform. Hence, this is symmetric. Now test B. We are saying A minus A transform is skew symmetric. For skew symmetric, so let us assume this as B. So B should be equal to minus B transform. Okay. Now, what is B? So let us take the transform of this. Okay. So minus, let us first find the transform. A minus A transform. This is B, right? I'm taking the transform of it. This will be A transform minus A. So and then we have one minus outside because minus B transform. This will be A minus A transform. This is nothing but again B. Hence this is also skew symmetric. This property is skew symmetric. Next C. Trace of A transform into A is greater than or equal to 0. So A transform into A greater than or equal, there is a property. So trace of A transform into A is nothing but trace is equal to, trace of this is equal to summation of Ij, okay, A of Ij square. Okay. So trace of A transform into A will give you the product. Okay. So sum of squares of all those elements in the Ij. In a given matrix, if you multiply, you can take an example and find it, you will always get this. So this is always greater than 0 because any element, when it's the negative element, A of Ij is equal to 3 also, I'm considering the mod value because I'm squaring the numbers. So what exactly it means, see, when I say A of 1 comma 2 is equal to say minus 3, in the matrix. When I take the transform, it becomes A of 2, 1 equal to minus 3. When I take the product, it is 3 square only. So that is how you get it. That is the concept here. So this is always true. Then please remember this property. Okay, one more problem we'll solve next. If A is Q symmetric, then trace of A is equal to 0 by the definition of Q symmetric matrix. Next, if A equal to 1, 2, 3, 4, compute trace of. So will you find trace of A transform into A will be given as summation of ij, okay, for all values in that matrix. You add them with their squares. Ij square, that is nothing but what? 1 square plus 2 square plus 3 square plus 4 square is 1 plus 4 plus 9 plus 15, should be 30. Okay. Next, which of the following is not always true for square matrices? A power k is defined for k equal to k greater than or equal to 1, right? Okay. Can find the product, right? Product of matrices when k is greater than or equal to 1. They are not saying k is less than or equal to less than 0. Then negative is different. So when it is as long as greater than or equal to 1, that means what? I can find the product up to k terms, that is a into a up to k times. So k is greater than or equal to 1. Okay. Now this is true. They are asking which is not always true. This is true. Next, B. A transform is square. Yes, if it is a square matrix, the transform of the given matrix is also a square matrix. This is also true. A plus A transform is symmetric. So you check here. A plus A transform is symmetric. Is it always true? And A minus A transform is always symmetric. So which one is true? So again you check the property. So A plus A transform is symmetric, means this should be equal to A plus A transform. That is, A transform should be equal to A for a symmetric matrix. That means that you see this as B transform, that is transform of this, or you can take B should be equal to B transform to take a transform of it. If you take the transform of it, I'll again get back my B, that is A transform plus A. This is nothing but entire thing is B. So this holds. So this is also true. A minus A transform is always symmetric. No. Previously I was saying it becomes Q symmetric. So this statement is false, because I'll get minus of A minus A of t when I solve this like that. Next, for 2 cross 2 real matrix A, which statements are true? Trace of A transform equal to trace of A. So is it true? Yes, it is true. So you take any matrix, trace of A will be trace of A transform, because the diagonal elements, the order may change, but the diagonal elements will remain same. Okay, so this is true. Diagonal A, the diagonal matrix A implies A transform equal to A. So diagonal matrix is symmetric, that is the meaning. So diagonal matrix can be symmetric. So this is also true. Then symmetric A implies A transform equal to A. That is the definition of symmetric matrix. Then skew symmetric A implies A transform equal to minus A. That is the definition of skew symmetric. So all 4 statements are true. Next, if A equal to 1 1 0 1, compute the 1 2 entry of A power 10. So already I given you. This will be equal to, if this is B into K, here 10 means K. So that is 1 into 10. So this K of 10, 1 comma 2 will be 10. So previously I gave this, right? If it is in this form 1 B 0 1, So if I take to the power 10, this will be 10 into, or take power k, it will be, this element will be AB in the multiplied k times. Next, a diagonal matrix is given 2, minus 1, 3. Compute trace of 2i plus a. So using the properties of trace, I can write it as 2 into trace of I plus trace of a. So 2 into trace of I. So three elements are then a diagonal, means it's a 3 cross 3 matrix they are given. So A is a 3 cross 3 matrix. Now trace of I means identity matrix. So it will be 3. So identity matrix of 3 cross 3, that is 1 0 0 0 1 0 0 0 1. So trace of this will be sum of diagonal elements, that is 3, plus trace of A. Trace of A means all the sum of all the diagonal elements, 6. 3 plus 5 and 4. So 10. 10 is the answer. So 10 is not in the option. So let us make it 10. So 10 is the answer. Next, for n cross n matrices A comma B, which are always true. So there are two matrices A, B, and which of them are always true. Next, okay. So trace of A plus B is equal to trace of A plus trace of B. So this is true. Trace of AB equal to trace of BA, that is also true. Trace of KA is equal to K into trace of A. This is the property of trace. Then D, trace of A transform equal to minus trace of A. So this is not true, right? So trace of A transform is not equal to minus of A. See, when I take the transform of a matrix, the diagonal elements remain same. So let us say 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my matrix A. If I take A transform, this will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the diagonal elements remain same. That means what? Trace of this both matrix will be same. So this is not true. If trace of A equal to 10 and trace of B equal to 5, compute trace of 3A minus 2B. So again apply the property. 3 into trace of A minus 2 into trace of B. So this is 3 into 10 minus 2 into 5. So this is 20. Next, compute the trace of I4 cube. So I4 means what? Identity matrix, 4 cross 4 identity matrix. So you already know the property. So trace of identity matrix 4 cross 4 means all, it is just like this. So for identity matrix, this is I1. So this will be trace is 4. Okay, this is 4. So if I take I power n, okay, I usually write it as IN. Okay. So this will be multiplying it 10 times, again gives me I only. Okay, or I1. So the trace remains same. So it will be sum of these elements, that is 4. 4 is the answer. Next, for a scalar matrix KIN, which are always true. Okay, so scalar matrix means what? K into some identity matrix 1 0 0 1. K is a scalar value here. So this is nothing but K 0 0 K. For example, 2 cross 2 scalar matrix. Now, is it a diagonal matrix? Yes, it is a diagonal matrix. This is true. Is it symmetric? Yes, 0 0. It is A is equal to A transform. This is symmetric. Commutes with all n matrices. Commutative property. That means if I multiply like this, A into KIN should be is equal to KIN into A. This is always true because it is I is an identity matrix. Multiplying both sides will give the same result. Okay. So this commutes true. So then trace of k into in equal to n into k, that is. So for this, if I take k 1001, so what is n value here? So this will be equal to k into trace of this matrix is what? 2. This sum of all these diagonal elements. So in a 2 cross 2 matrix, I have 2 diagonal elements. If it is n cross n matrix, I will have n diagonal elements, that is k into n. This is also true. If A equal to 2 into I3, that is 3 cross 3 identity matrix, compute trace A power 4. So we already know this property. A power 4 is equal to, this is I can write it as, or A power k is equal to 2 power k into I power 3. Remains same. Okay. So there I power 4 means 2 power 4 into I3. So trace of I3 is 3. So 16 into 3 is 48. This is the answer. So we'll solve few more problems in the next video and some more concepts. Okay. Please like, subscribe and share. Thank you for watching. We'll continue in the next video.